Mr. Bansal has obtained MS in Chemical Engineering from University of Alabama and BTech in Chemical Engineering from IIT Kharagpur. Mr. Bansal is a co-founder at Factorian and a leading expert on process analytics and focuses on building software analytic products for the process manufacturing industry. He has 20 plus years of experience with process analytics, process development, scale-up, technology transfers, and manufacturing. And his previous employers include Amgen, Abbott, DRL, and Simplify, which was later acquired by Merck in 2018. So let's welcome Mr. Bansal.
So I'll step back a little bit what Anurag was speaking and move more into the tech space, a little bit less biotech, but where all the models will run, how we'll be basically doing storing the data, where will be doing the storage of data, where will be doing the computation power. So can we step back and how can we improve it in the 4.0 paradigm, and also can we learn something from the cloud computing in that space so that we can implement those technologies doing real-time analysis, basically. So basically my past slide, I think it's already told by Partha. I'll just skip this slide. So what exactly is Industry 4.0 is basically, as we all know, is basically starting from steam power in Industry 1.0, then we move into electricity, then processing of data. And now the data is, once we have data, what will you do with the data? So I think that the Industry 4.0 is all about data, how we handle the data, how we manage the data, how we can basically improve our processes using data, right? So in order to do that, we have to understand what exactly is biomanufacturing data space looks like, right? So this is typically, we have given a graph here showing where the data gets generated, right? And then it gets generated in manufacturing space, it gets generated in engineering space because you're doing a lot of building monitoring and all the stuff you're doing. You're creating a fitness of your facility, you're creating a fitness of your processes when you're doing process development. So you're generating all this data, and how do you basically store this data? How do you basically get access to this data is really important, right? So once you overlay this data paradigm and the kind of tools that are available in the industry right now is basically a graph like this, saying in the green we're saying is more of IT-driven data structures, which is typically your ERP system or your LIMS system, your quality management system, which is typically more manual data capture steps. Whereas the yellow portion is showing what is typically a OT network looks like, meaning a lot of data coming from your manufacturing network, from your process machines, from your process equipment, right? And more we are going more into the Industry 4.0 paradigm. The data from yellow portion will start to bloat up, and the green portion might probably remain same or go down. So that's the reason we have to be getting ready for the data deluge, handling the data deluge that we're getting once we move more and more into the automation space. And what Anurag was speaking about is when we are starting to get a lot of data and we want to do real-time crunching of the numbers, how can we basically handle that kind of a data that is basically going to overshoot what we can handle right now. So currently what happens in the industry is the kind of tools that we use, the kind of software and hardware that we use are not geared for that. So Factorian that we are working right now is typically geared towards that, is how can we basically make the industry ready for handling that amount of data in a real-time manner. So typically what we do with this data set, as Anurag was pointing out, is getting a lot of this data in the process development space, a lot of this data for process monitoring and continuous process verification space. And for all of that, we need data basically in real-time manner and real-time number crunching that we want. So this is a typical example of any process that we're seeing, and we're seeing that a lot of this data which is right now generated is all manual. So we keep this data in a lot of Excel spreadsheets around, but that is not really accessible for us to do basically data crunching in a real-time manner. So as you can see here, there's also a problem of data diversity. So we have these equipment vendors that we have, and they follow typically their own standards. They have their own protocols for communication in the process machines. All the PLCs and SCADAs that we use may have a different protocol. Some may speak Profinet, some they speak Modbus, some speak OPC. So it becomes difficult to capture the data in a real-time manner so that we can have a consensus and contextual data available for us to do real-time crunching, right? So for that, we have to basically go to a different paradigm. And there's some problems that we see. There are typically three problems we see in the industry that has to be tackled right now. The first one is too many communication protocols. I think the industry is really working on that, and slowly I think we will get to a consensus that a typical format structure will be available for people to have a communication platform that will be easy to communicate with. I think that a lot of people are working on that, so we are not tackling that problem right now. We are talking mainly right now is how can we combine the IT and OT systems. The green and yellow, how can we basically have a common infrastructure where an ERP system can talk to your machines directly, or can we have data coming from your LIMS system and can have fusion with the machine data directly, right? So that's an important thing we have to work on. And they all reside in a different silos right now. I'll be explaining that as well. Third point is we have rigid computing infrastructure right now. So whenever you go to your IT basically, and they say we want a new computer, or we want a new computing space, they take so much time to basically provision a new computer to you, sometimes, or a server to you. So we have to basically move into a paradigm where the computing space is readily available to you so that you can expand your infrastructure and models very quickly. So in that case, the RAMs and CPUs and historical data capacity has to be adjusted and be elastic. So that's what is important for us to move into that space. So our Factorian, basically, we are trying to solve the last 2 points of software and hardware. Can they reside in the same space? Can they be fused from IT and OT systems together? And can we have a hardware that can be basically elastic and adaptable and redundant? So in continuous manufacturing space, you can't afford to lose your data, right? To lose your manufacturing process also. And you can't afford to have your software shut down or hardware shut down, right? So in that case, you have to build redundancy, highly available infrastructure. So for that, we have to basically learn from cloud computing space. So that's what I think. Let's go back and do a status quo right now. So what traditionally right now, how the data resides is, you have this, your machine is basically pretty far off from the data where it resides. Right now, a lot of the data resides in site server room or corporate data centers, right? And that typically is managed by IT. And whereas your OTs, basically, which is operational technology, a lot of machine data resides in machines, and they don't have any communication with the data centers. So that's what it's a lot of silos right now, and then to make the real-time continuous operations possible, you have to break down these silos. So just to elaborate on the status quo again, a lot of these yellow and greens basically right now is typically spread out miles across. So right now, they're not typically in the same vicinity. So latency issues become an issue. You can't respond to the processes in real-time manner. That becomes an issue, right? So typical challenges that we see in the data center is long lead times, IT provisioning is an issue, scaling of compute and storage power is an issue, and high cost of redundancy and high availability. So that becomes a problem. So you can't be flexible enough to create new processes, or introduce new processes on the plant floor. Second is the hardware issue that a lot of the vendors that provide us the hardware, the SCADA system that provide, they are tightly attached to the machine. And the problem with that is you have limited capacity of CPU and RAM, so you can't run your models and AI ML models typically on those machines. That becomes a problem. So what we are saying is, can we learn from cloud technologies? Can we bring the cloud on-prem? Because there's a lot of problem with the cloud anyways, because we can't take all the data on the cloud because of latency issues and everything. So, but we can learn a lot of things from cloud technology because it's perennially elastic. We can have elastic storage and elastic computing. It is typically fault tolerant. We can do quick provisioning. We can do highly redundant and highly available systems, right? So now the key enablers that are cloud, that we can learn from the cloud technologies are software-defined storage. Can we define the storage which is not hardware specific? So it automatically becomes a virtualized ways of doing the storage. There's a new technology which are coming up called containerization or Kubernetes, which is basically about how do you maintain and how can you create a virtualized environment of an application itself that can run on a sea of hardware. So that becomes, you're basically detaching your softwares and your infrastructure from the hardware. So So it can become more redundant in that case. So a lot of these technologies we are evaluating, and we can bring down a lot of these cloud technologies onto the plant floor, so that it becomes much more easily available for people to do real-time manufacturing. So, but the problem is we can't take this to the cloud because of latency issues, high cost of storing the data on the cloud because Amazon or Google, you don't want to store your data on the Google or Amazon clouds, right? So that becomes a problem. So typically for highly regulated industry, we want to bring the data on-prem. So we have to bring the cloud technologies on-prem anyways in that case. So what we propose is basically create an infrastructure which is more scalable. So what we are doing is we are creating the container engine orchestration where the applications will run on top of it, and that will keep on running, even if you're removing one hardware and replacing that with another hardware. And then hardware, basically, you can add more and more hardware to that, and automatically you keep on increasing your RAM or the cluster and your core. So in a sense, we are bringing the cluster technology on-prem. So right now, it's not available as a readily available commodity hardware mode. So that's a problem. So right now, the clusters are available on the data center side, but not on the plant floor. So can we bring those cluster technology on the plant floor so the plant can run in a continuous manner? So that's what it is. We are bringing elastic, scalable, redundant, and highly available infrastructure on the plant floor. So I'll skip this slide. So typically what we'll do is we are creating these boxes which are low-powered, running on ARM architecture, which is typically a new chip technology coming in, replacing Intel, which basically take a lot of low power. And you can have a lot of backups running in the system itself so that you can have, it has its own redundant power built in with a lot of these lithium-ion cells. So what you can do is you can stack these boxes on top of each other. As you want to scale your operations, you can keep on adding, and automatically all your infrastructure will get scaled up. So what we are trying to envision is we can basically put these boxes near the plant floor all along the company, and you can basically start getting the data in the real-time format. You run your applications that can communicate with each other very well. So we can basically infuse and connect IT and OT systems together, so that the data is available real-time in a real-time manner. Okay. So basically, that's the whole idea, is to move the data center closer to the manufacturing space, and so that we can basically create an infrastructure that is more scalable and more redundant in terms of operations that we want to gear us for the real-time environment, basically. So I think that's what it is. And also, it has a lot of quality benefits because you can your deployment time for a software or a new improvement in process technologies become much more shorter, and you can de-link your hardware compatibility to the software and the controlling software to the manufacturing machine in terms of qualification much faster. So I think, so when you de-link your manufacturing hardware or the computing hardware to the software, then your deployment time goes tenfold or fivefold, basically. So you can basically deploy and change and adapt much faster compared to the current monolith hardware and software combination that we have currently. That's what I want to say right now. Thanks.